If we take any kind of synchronization mechanism, generally they will be classified into two types. One will be with busy waiting solution, and another one will be without busy waiting solution. With busy waiting means, if I say, let me take an example, something like a kind of dressing room where you have a door and there will be already one person inside here, and by making certain kind of indication, occupied or vacant or what it might be, right? When I would like to change for some dress, I will come here, I will check whether it is occupied or vacant. Is it occupied? Yes. When it is occupied, what I will do, I will try to always knock this door. Please come out, like that, right? That is what we call it as with busy waiting solution. And without busy waiting solution means, once I check the room is occupied, I will simply come out of that location and I will go for sleep. Once the person comes out, he is the responsible for to wake up me so that I will enter into the room. That is what I can say, that without busy waiting solution, right? So in with busy waiting solutions, what is the one problem? One will be bounded waiting. Definitely there is no chance of bounded waiting. Okay, now, so that is what you have to understand. So generally synchronized mechanisms are of two types. One is with busy waiting solution, another one will be without busy waiting solution. With busy waiting means always it is eager to waiting to enter into the critical section, so I can say this as a critical section. Whereas in without busy waiting solution, once it has seen somebody is there in the critical section, I'll just go for sleep, and if somebody will comes out, they have to wake up this particular process. Okay, now fine. So we'll take one of the simple synchronization algorithm, that is lock variable. So lock variable is a kind of a software used at user mode, guys. Used at user mode to implement any kind of synchronization solution, and which is comes under with busy waiting solution. And we can use this particular lock variable software for n processes. Okay, now, so in general, if I say here, again I will take the same example of dressing room. There will be a door, right? Initially nobody is there, which means I can say lock value as 0. Lock value as 0 means if I observe here lock value as 0, I can understood that this is a vacant room. And when I am observing here as 1, I can say that this will be an occupied one, right? Now observe how can we write this particular code for acting as a critical section. Means my requirement is here, I should not allow more than one person inside the critical section here, right? So if I take simple code, while the lock variable is not equal to 0, which means what? While the lock not equal to 0, I am going to be in the waiting state. I am going to simply making the busy, right? Which means that what you can understood, as it contains the 1, I am going to completely wait here. Is it okay, everyone? And once you observed here lock as 0, observed here as lock as 0, I will go to the next statement. That means what? I will make the modifier as lock as 1. I will enter into the room. Am I right? I will enter into the room. And while I am coming back, what I have to do? Again, I have to update it back. Update back, right? Is it okay with everyone? Yes. So now, observe this is line number 1, line number 2, 3 and 4. Right? With respect to here, is there any violation? What you observed according to the critical section problem, critical section requirement? Process P1, person P1 is executing the line number 1. Line number 1. Initially it is 0. So it will go for, so lock will be 0. Right? Will the first line is going to be executed? Yes. Is it going to be the loop or go for the second step? Second step. Good. It will go for the second step and make the value as 1. Make the value as 1 and I will enter into the critical section. Critical section. Then I will be there. Critical section. Now assume I am there itself and somebody might come. Right? Person 2 might come and as he observed here, right, it is executing the line number 1. As he observed, is lock not equal to 0? Yes, he is going to be still in this particular procedure only. Particular procedure, right? Which means what? He is going to be an infinite time here. Infinite time until the other person comes out. The other person comes out. So that is the reason I am saying that it is a kind of busy waiting solution. Until other person given a chance, I have to be always knock the door, and so on. Right? We can simply say that it is going to be an infinite solution, and I can say this as busy waiting. And assume that again the process P1 got the chance. I will complete the critical section. I will make the lock as 0. Once I make the lock as 0, can I get to some other process again for some P2 or P3 or whatever it might be? Or not? Yes, right? Yes. So P2 got the chance and it will go for execute. This is okay for you? Yes. There won't be any problem with respect to this explanation. Right? But in general, if you are going to write with respect to assembly level language code, with respect to assembly level language, how can we write the while lock not equal to 0 code? First I will try to load lock value into the process register Ri, and second one I am going to compare Ri value is equal to 0 or not. Is equal to 0 or not. If it is not 0, means jump if non-zero, jump if non-zero, I am going to go for step 1. Then I will perform the fourth step as what? Lock equal to 1. Then I will go with the lock critical section. Then I will go with the, so I should not write like this directly. I have to go with the store #1 into the lock variable. Lock variable. And here I have to do store #0 into lock variable. Now observe the case. This is first statement. Assume that process P1 is trying to enter into the critical section. When process P1 is entering into the critical section, the initial value of lock will be what? 0. Lock will be 0. Now here you are going to have a register or not. First executing the first line, that will be a 0. Am I right? 0. execute the first instruction, good, and preempted. Executed the given chance to P2 and execute the first instruction. Again R1 with value what? 0. Am I right? Given preempted, given chance to P3, executed the first instruction and it contains what? R2. This will be R1, right? R1, R2 and R3 because they are the processor names. R3 it contains 0. Observe, now if it got the chance for P1 once again, what will happen? P1 is going to compare R0 with 0. P1 compare R0 with 0. When comparing R0 with 0, is it equal to 0? Yes or no? Yes. When it is equal to 0, it will directly go for line number 4. When the statement number 3 is going to be executed, when it is non-zero, means when it is not matched, it will go for step number 1. But as in this case it is equal to 0, it will go for executing the fourth line. Fourth line, lock value will be modified to what value? 1. And enter into critical means 2, 3, 4, critical section enter. Assume that it is executing and P2 got the chance. P2, what it is executing? First done, second time onwards it is executing. Second line is what? R2 comma 0. Is it R2 comma 0? Is it locally? Locally you have to check. Is it R2 equal to 0 or not? Yes. Then it is going to execute again store hash 1 comma lock. Means it is going to perform 1 with 1 and will go for executing 2, 3, 4 critical section and so on. I have observed the problem what is facing here. Right? Which means so far how many process entered inside the critical section? P1 is already entered. Now P2 is entered. If this process continues and so on, Pn process might enter into the critical section. Might enter the critical section. Means, can I say that is it violating mutual exclusion property? Yes. As it is violating mutual exclusion property, I can directly close this algorithm here itself. I don't want to discuss further properties because this is the primary goal. Primary goal, right? So, as it is violating the mutual exclusion property, I don't want to discuss this one. Instead, can I improve further? That is what you have to discuss. Right? So, what I am saying is, if I go with the first line, I am trying to perform load, lock onto array process. And then I am performing comparing array with 0. And then if it is not 0, then it is going to go for step 1. Otherwise, I will make load or store hash 1 into the lock variable, critical section, and then load hash 0 into the lock variable. So, hope you understood what is the problem here, right? When the preemption is going to be happen here, definitely there will be a problem. We might improve this particular thing with certain solution where if you are able to eradicate the preemption here, definitely there will be some improvement in this particular code, right? So, which means I can say load lock of Ri and immediately I will perform load hash 1 into the lock. I am just interchanging statements. Fourth statement is shifted to the second statement. And I am going to perform comparison Ri comma hash 0, jump if non-zero, step 1, critical section, load hash 0 comma, which means this is statement 1 now, statement 2, statement 3, 4 and statement 5. When you are modifying this code, definitely there will be some improvement. I mean here you are failing almost 100 failures because of preemption at this point. Suppose for example in the earlier algorithm itself, if you did preemption here. Again, the same 100 failures are going to be happen. But in this particular algorithm, if you are going to observe, if the failure is going to be happen here, what might be the happens? As log contains already 0, already 1. Observe, I have already updated with 1. As it contains already updated with 1, it won't give chance to other one. It won't give chance to other one. That is the advantage of this particular algorithm. But again, the thing is, there might be a situation where mutual exclusion again not possible. Why? Because there might be a situation where line number 1 itself preempted. If line number P1 is preempted, P1 one line preempted, P2 line number 1 is preempted, P3 line number 1 preempted, and so on. What will happen? All the locally it contains the value 0. Local register it contains the value 0, and after performing the value 0 to the locally, then it is updating with the value 1. Is there any use of it? No, because comparing RA with 0 is equal to what? As locally contains all values are 0, it will allow entry into critical section. Means again n processes are going to enter into the critical section. Is this right? No, n processes are going to enter. P1 contains the value as 0, right? P1 contains n values as 0, and later execute the second instruction. Then what will happen? Lock value will be updated with 1. 0 will be 1. Undo. Compare Ri comma has 0. What is the local value of register? 0 with 0. Match. When it is matched, enter into the critical section. P1 entered. Then P2 will come. Compare 0 with 0. Yes, P2 will enter, and so on. Pn will enter. Right? As all the processes are entered into the critical section, again, this is not achieving the property of mutual exclusion. Right? For this, the solution will be, they come up with a solution, they are going to be executed these two atomically. They are going to execute atomically. When they are going to execute atomically, which means that there is no preemption between these two statements. Right? So I can be written this as TSL, test set log, is a kind of new technique where if I write this code, these two statements are going to be executed atomically. Test set log, log comma R, log comma Ri, and then I am going to perform comparing Ri comma 0, jump if 0, if non-zero, step 1, critical section, load, hash 0 into the lock variable. First statement, second statement, third statement, and fourth statement. Now observe what this TSL will do. TSL will first test it, whether lock contains 0 or not. Try to understand whether lock contains 0 or not. If lock contains 0, it will update it to 1. If the lock contains already 1, it will simply eject it. It simply reject it. Okay now. So which means that if lock is 0, update it with 1. If lock is 1, it won't be updated, and simply it will be in the waiting state. Simply in the waiting state. Now try to observe the solution. If process P1 comes into the picture, line number 1 is executed. When line number 1 is executed, lock is going to be 0, and register R1 contains what value? 0 or not? Yes. This R1 contains 0. Now this will be modified to which one? 1. Why it will modify to 1? Because it is the property of TSL. TSL will check the value as 0 or not, then update it to 1. Right? Next, if it is preempted, again if P2 got the chance, P2 contains what? R2. R2, and execute the first statement. If it executes the first statement, what is the value of L? 1. Then what it will do? It won't allow to modify or update it. It will simply go for waiting state until it will update with what value? 0. Update with what value? 0. Now, if P3 got the chance, again it is going to be in the waiting state only. even if you got n process, all are going to be in waiting state only. So at the end, definitely you have to give chance to what? P1. P1 will execute line number 2. Is it equal to 0? Yes or no? Yes, it is equal to 0. And as it is non-zero, enter into the critical section. Then definitely it will execute the fourth step. Then it will comes out. While it is comes out, load of hash 0 comma hash 0 comma log. Now, out of this process which are in the waiting state, waiting solutions, they might be entering into the next process. Hope you understood? Now, in this particular algorithm, in this particular TSL algorithm, how many processes entered in the critical section at a time? Only one process, right? So, can I say that mutual exclusion is guaranteed? Yes. As only one process is going to be allowed inside the critical section, mutual exclusion is going to be guaranteed. So, as the primary goal is satisfied, the another primary goal is should be progress. Is it satisfied? Yes. How it is satisfied? Means so generally progress means what? The process which are not interested should not stop other process to enter, right? If I am not interested, I am not going to execute this TSL statement itself. Am I right or not? If I am not interested, like I can say, the processes which are not interested won't execute TSL instruction itself. Then what will happen? Definitely the other interested process will get the chance to execute the instruction. So that is why you are going to achieve the progress. Then what about busy waiting? And what about architectural neutral? What about busy waiting and what about architectural neutral? First tell me architectural neutral. Architectural neutral is not possible. Why means, in order to execute the TSL instruction, this is a kind of set of instruction code where it is a kind of special instruction. Two instructions has to compulsory executed in an atomic fashion. For that you need separate implementation of the hardware. That's why it is not architectural neutral. And busy waiting, is it comes under busy waiting? Definitely, because P1 completed, immediately again P1 might be allocated. Right? Means once P1 completed, again P1 completed, again P1 completed only. Means even continuously 1000 times P1 completed, even I am not getting the chance. Can I call this as a busy waiting solution or not? So here busy waiting is not going to be not satisfied. Right? This algorithm we called as test set lock algorithm. So this algorithm requires special hardware and busy waiting solution is not satisfied. Progressive and mutual exclusion are going to be satisfied.